So good morning, good afternoon, and good evening, everyone. And thank you so much for joining this talk. My name is Sonal Patil. I'm a principal program manager at Microsoft in a group called Commercial Software Engineering. And today I'm here to talk about DevOps and how understanding DevOps can help us implement DevOps better. So when I started my DevOps journey, the first question that came to my mind was, what is DevOps? I asked around a few of my colleagues who were fairly new in their adoption of DevOps. And they told me it's like CICD pipelines, automated testing, test-driven development, etc., etc. But is that what really DevOps is? How do you define it? So I did a web search. There were a lot of results. Some of them said DevOps is dev and ops together. But how does automated testing, for example, fit into putting dev and ops together? So then I decided to research the origins of DevOps. Where did this name come from? I found out it kicked off somewhere in 2007, 2008, and the concept of DevOps came from applying the principles of software development to IT infrastructure management. In 2009, there was an O'Reilly conference where the director of engineering, i.e. Dev, and the VP of Ops from Flickr did this talk called 10 plus deploys per day. It's quite an entertaining watch, and the talk is on YouTube, and I'd really recommend to go and watch it because they did like a role play on how bad things were at that time. But also, all of these practices that we now take for granted were being introduced for the first time. So now I knew how it started, but what is it exactly? Can it be defined? And to find out more, I referred to a couple of books. The first book, The Phoenix Project, defines DevOps as the outcome of applying lean manufacturing principles to the IT value stream to accelerate the flow of work. The DevOps handbooks now then takes that definition and it defined ways or paths to apply that to real software development. It defines 3 ways to apply DevOps and talks about the principles behind each ways. This probably is still too high level, and there are probably some engineers in the audience thinking this is so typical of what a program manager would say. In this talk, what I attempt to do is try to make the connections between the principles and the practices of DevOps. I've structured this talk to introduce each way from the DevOps handbook and then examining how certain DevOps practices that we already do contribute towards those principles. So let's start with the first way, the principle of flow. The principle of flow is about establishing a value stream that delivers value to the customer. Any work that delivers value to the customer is part of the value stream. Do you write automated tests? Yes. Is it going to deliver value to the customer? Yes, because they're going to see less failures when the product is in production. Then that's part of your value stream. Do you write infrastructure as code? Yes. Does it deliver value to the customer? Yes, because they can easily set up new environments. So that's part of your value stream. Anything that delivers value to the customer is part of the value stream. The value stream goes from left to right, or from dev to ops, or from business to the customer. So with this definition in mind, the first question I'd like to ask is, why do we have a sprint board? The first way tells us it is to make work visible. Unless your work is visible, you cannot establish or optimize your value stream. This is the most basic starting point of any DevOps implementation, especially for technology work, right? Because it's more or less invisible. There isn't a car produced at the end of the assembly line. Often there's friction between engineers and the managers who think, why is something taking so long? It's just a few lines of code. Or the frustration you feel when you've spent 2 or 3 sprints writing a beautiful API, but you don't have anything nice to demo. Putting your work on a sprint board helps us visualize that work and see where it's flowing well and where it's stalled. Also remember, work is only considered done when it's running in production, delivering value to the customer. So the next question I would like to ask is, why do we work on one task at a time? The answer to that is to limit work in progress. Time taken to complete even simple task significantly degrades when multitasking. Picture this scenario, right? You've got a project deadline and you've got so many things to do in this one sprint. You start working on all your tasks at the same time. You've got 6 tasks open, you're switching back and forth between bugs and new functionality. You lose your flow constantly switching back and forth. You wanted to finish stuff faster, but you end up taking more time or quality suffers. To, to prevent this scenario, to prevent this from happening, you want to limit your work in progress. The next question to ask is, why do we commit small changes in pull requests? DevOps principles tell us it is to reduce batch sizes. What that essentially means is you want to chunk your work into smaller parts and finish that part before beginning another. To demonstrate that, I'd like to show you 2 flows, right? The first flow, you can see all your changes are grouped together. They're committed, tested, and grouped together in a single code review. The code review probably takes longer because there are more files to review and maybe some merge conflicts. The deployment probably takes longer as well because there's more configuration and again, possible. You can see there's a very shorter and problems are quickly identified and value is delivered to the customer a lot sooner, which is why we want to reduce batch sizes. So the next question to ask is, why do we dev, test, and operate our own code? Now, this appears to be a pet peeve among many engineers I've spoken to. Why do I have to test my own code? I used to have a QA team before. Now, why don't we have an operation teams? Why do I have to carry a pager, for production? The answer for that is to reduce the number of handoffs. Every time work passes from team to team, there's a set of communications and context setting that's required. You have specifications, prioritization, ticketing systems, scheduling, documentation, meetings, emails, and whatnot. Yet, every time a handoff happens, context is lost. Every handoff is a potential queue, and each queue is a potential bottleneck. And when you have a bottleneck, the flow of work is stopped or interrupted, and it's not going to the customer. So the next question, why do we have CI/CD pipelines? And the answer to that is to remove constraints from the flow. To demonstrate this, I've put up this picture. This is the waterfall model. And if you're about my age, you've probably lived the dream, or should I say the nightmare. In the waterfall model, each step must happen in a specific order. So each step is a constraint for the next one. For example, you cannot start requirement specification until you finish analysis, which means analysis is a constraint for requirement specifications. When we start applying DevOps, we start removing constraints. So I'm going to remove the environment creation constraint by writing infrastructure as code. Now the development is not constrained by an IT infrastructure team. Next, I'm going to remove testing and integration and deployment by adding CI/CD pipelines. What happens now is the delivery to the customer is not constrained by sign-off by a test team, neither is it constrained by deployment by infrastructure team. All of that is done through CI/CD pipelines automatically. As soon as work is committed, it is tested and deployed automatically. Let's remove some more constraints. What about design and architecture? You can remove that by having a loosely coupled architecture. The development team is not constrained anymore by a team of architects handing them architecture. Design stays in the realm of the development team. What's interesting now is if you look at what is left, it's analysis, requirement specification, and development. All these are activities that can be done by the DevOps team, which is the product owner or the developer. And when you have a DevOps team that does not have any external constraints, that's when they're best placed to give value to the customer. So we looked at the first way and all the principles in the first way. Now let's look at the second way, the principle of feedback. We've established the value stream from dev to ops, and now we need to make it a safer, more resilient value stream. The way we do this is by fast and constant feedback from left to right. The feedback comes not just from the customer to the business, but from all stages of the value stream. Let's look at some of the DevOps practices that help us with this feedback and how they relate to the principles. So, first question here, why do we peer review code in pull requests? And second way tells us it's to push quality closer to source. Peer reviews give us a quicker, closer feedback loop. They allow us to detect and remediate problems when they actually are cheaper to fix than when they get amplified in production. A stitch in time saves 9, right? Peer reviews also make quality everyone's responsibility and not just a responsibility of a separate quality assurance team. Having developers share responsibility for quality not only improves outcomes, but also accelerates learnings. The next question, why do we do automated testing? The answer for that is to see problems as they occur. If we wish to build a safe, resilient system of work, we have to constantly test not just our code, but also the design and operating assumptions. Also, the automated testing again provides you with a shorter, quicker feedback loop. So why do we stop to fix a failing CI/CD pipeline? And like I said, I receive a lot of pushback to this. Like, do you literally mean stop working? The whole team should just stop working to build an automated pipeline? The second way says, yes, you should, because you want to swarm and solve problems. It's not just sufficient to detect problems when the unexpected happens. We have to mobilize, put our heads together, and fix those problems to get the flow of work going again. A very good example of this is the and-on cord at Toyota. In all Toyota manufacturing plants, at every work center, all workers and managers are trained to pull a cord if anything goes wrong at their work center. So for example, if a part is missing or defective or work is taking longer than it should. Once the cord is pulled, the team leader and the worker try to resolve it for 60 seconds or nearabouts. But if they're not able to resolve it in that time, the entire production line is halted and the entire organization can be mobilized until either the problem is fixed or an acceptable countermeasure is found. Instead of working around the problem to fix it later, they swarm to fix it immediately. The same principle can be applied to software development as a virtual and-on cord. If a build or deployment pipeline is broken, then the flow of work to production is essentially stopped and a value stream has stalled. Instead of postponing the resolution of a problem, we need to swarm together to either fix it right away or put a countermeasure in place for as long as it. So now we move or come to the third way of DevOps. This is the principle of continual learning and experimentation. We've built a value stream. We've made it safer and more resilient. Now we need to make it a better and more improved value stream. And we do that by continual learning and experimentation. We need an organizational culture of experimentation and learning where all of us are empowered to learn from our successes and failures. And so the final question I'd like to ask is, why do we have retrospectives and sprint reviews? The third way says is for the improvement of daily work. Learning is not just about learning new technologies or frameworks. It's also about improving how we do work. It's a well-known saying that in the absence of improvement, processes don't remain the same, but degrade due to chaos and entropy. By applying the scientific method to both product development and process improvement, we learn from our successes and failures, identifying ideas that don't work and reinforcing ones that do. Remember that even more important than daily work is the improvement of daily work. So thank you so much for listening. I hope that looking at the DevOps practices from the perspective of the principles behind them will help you drive the adoption of these practices even better with your teams. I would love to hear your views on why you think we should do DevOps and some of your experiences in implementing them. Thank you very much. I'd be happy to take any questions at this point in time. Looking at the chat. DevOps works outside of DevOps. Yep, it's all about the 3 weeks. Absolutely. And swarming is fabulous method, Simone. I would really recommend that. It really encourages learning in the team. It's a very good team building method as well. And it also encourages helping your teammates. Basically, it's not a DevOps engineer's problem if things don't work, right? It's everyone's problem. So definitely encourage people to, next time you have a failed pipeline, just get together, put your heads together and solve it. I'm going to check Q&A if you have any questions there. Oh. Got some comments about the waterfall method, which can be very long and wet. Absolutely. As I mentioned, I've referred to these 2 books that I mentioned earlier, the Phoenix Project. It's a kind of a novella. It's very interesting read as well. And it tells the story of an IT manager and how they move from having kind of a dysfunctional team to how they apply DevOps to make it a better functioning, more effective team. And the DevOps handbook gives you really specific examples and really something that you can actually implement on how you apply these principles as well. So Jessica, what is the hardest part of DevOps implementation with customers? I think the hardest part is just the change in the mindset. And it sounds like something that people say often, but it's literally that, like, developers think they're developers, testers think they're testers, you need a DevOps engineer, you need IT engineers, and the change in mindset that should be a team of people through the verticals, right? And it's okay to invest your time not writing code, but fixing a pipeline. That's your work as well. It's okay to do that. It's okay to spend your time in writing tests and not fixing a bug. So that change in mindset is very, very important. And that is the hardest part, I believe. Thank you, Simone, for that wonderful link as well. Thank you. Don't see any more questions coming in. I have Shivani. You've got my LinkedIn ID there. I would love for you to connect as well to LinkedIn. Let me know how you think. I've got an article on LinkedIn as well that talks about these DevOps principles. I've also got another article that talks about multitasking and context switching mainly, and why that's bad for you, or why I think that's bad for you. So I would really love to see your comments on those as well. Just checking on how long this session's meant to be. Thank you, Jessica, for sharing that. Does anyone have any stories about DevOps implementation or anything that you'd like to share about how things were difficult for you, and how? I would love to have any feedback if putting these practices from the perspective of the principles. I thought I just flipped it a little bit. So you usually talk about principles and okay, this is how you implement the principles. But did you enjoy having that flip of looking at the practices and then seeing how they align with the principles? I've had success selling DevOps this way, right? I've had success selling those practices this way, because usually when you tell people, hey, do this, that doesn't work, right? We're all intelligent people here. We need to know why we're doing this. And this is why I kind of put this together. I've used this method of talking to a lot of my engineers, people in my team, and they really appreciate having that perspective behind why we do certain things. Okay. All right. So if there are no more questions, it was a real pleasure to talk at the Women's Tech Network. And you've got my LinkedIn, you've got my contact details there. Get in touch. Let me know your experiences with DevOps, and we can learn from each other. Thank you so much.